Hey everybody, thanks for joining me. This is All Aboard, Transforming Software Delivery using Spinnaker. A little bit about myself. I'm the manager of Cloud DevOps at Redbox. But before that, I was in the Spinnaker community for 3 years, since it's basically an open source release. In addition to that, I was a user of Asgard. It's kind of the predate Spinnaker. It's Netflix original delivery tool. There's my Twitter. You can find that at the end as well. And I'm also a GDG organizer running meetups out of Chicago. So I do that in my spare time. A little bit about Redbox, for those of you who are not familiar. Our primary source of business is selling and renting discs and Blu-rays out of kiosks across the country. If you're a customer, thank you so much for being a customer. We really do appreciate your business. But to further that, we are also getting into the on-demand space as well. So being available on web, mobile, and TV, right within the comforts of your own home. So definitely check us out. So a lot of us in the room have probably been asked and tasked with transform software delivery, this wide concept of transforming software delivery. And now that, you walk out of that meeting, you're like, okay, great, where do I start? When I was initially asked this question, I didn't have the answer. But fortunately, today I do. And the answer is actually very simple. Use Spinnaker. That's my talk. Thank you so much. No, I'm kidding. If it was that easy, we wouldn't be having a great conference learning from one another of how we use the tool in our various organizations, right? There's definitely a lot of things that have to go into Spinnaker as well, and we'll be touching on some of that today. So throughout this summit, we've heard the concepts of a paved road, right? And building the concepts of a paved road. For those of you not familiar with the concept of a paved road, it's essentially building best in practice tooling and ultimately laying out a delivery method so everyone can drive the same path. Whenever you're laying a road, the goal is to have as much traffic and have it the fastest way through like a jungle or whatever. It's all great in principle. You add more features, everyone on the paved road gets new features, you add new exits, everyone has the ability to exit at different various stages of that pipeline. And it's well understood, right? A road goes straight. It leads you to your destination. However, sometimes paved roads look more like this, more like a gravel road. And we're asking, where do we start, right? What do we do? How do we get this actually rolling within our organization? And whenever I'm tasked with a challenge of doing software delivery changes at any company I've been at, I always start at looking at the current delivery principles and laying them out. So what I mean by this is really lay them out. The concepts I just shared here, the one on the left, it's great in principle. It has a lot of the things that you should consider, but that doesn't really apply to your business, as we all know, right? If it was, then that would just be the prescribed approach. The one on the left, or the one on the right, apologies, it's too complex. To me, it looks like Candyland. I mean, I really don't necessarily need to document that I'm sending an email, right? I need to know the process behind that actual action item right there. It's pretty crazy, So before doing any work, if ever you have to do this kind of a mission, focus on the end goal, right? Don't worry about the technology used. If you do it properly, it won't matter what you use, right? You'll still be able to deliver software at an effective pace. Learn your skills and proficiencies within your organization early. If there's no one in the company who knows how to use Docker containers, don't start with Kubernetes, because I've always seen this kind of come up, you're going to fail. It's going to be tough, because you're learning 3 very complex topics in one go, right? Start small. I mean, for us at Redbox, we started with Docker Compose on EC2. Probably not the coolest thing on the block, but guess what? It instilled the practice of, I know what a container is. All right, it's been 3 months. I need a way to deliver that container faster. Okay, let's look at concepts like Swarm or Kubernetes. And that kind of built and instilled that confidence within our development staff, as well as our operations teams. And really, learn what the actual pain points are in your organization, right? There's obviously been a problem. That's why that task has been given you to solve software delivery. Ask yourself, what's the problem, right? What is the problem? Lay it all out and figure out systematically what is taking long in that process of delivery. Another thing, too, to consider is determine the core requirements. What are your delivery targets? What are your architecture requirements required to run your business? At this phase, you have to kind of consider what is truly needed, right? You don't want to just lift and shift if you can avoid it. You should, because you're going to bring the cruft along with it, right? The goal is to deliver faster cloud-native applications if possible. VMs, serverless containers, all of them, I don't know. Every business is different. At the end of the day, they're compute resources, and that's what we as engineers should see out of this. They all have their own use cases. They all equally have their own challenges. Again, that's up to you to figure out what's right for your business. Business requirements, right? It's not always all tech. What environments are you going to be deploying to? Are you in a data center? That's totally fine. Are you in the cloud? Great. Are you in GCP, AWS, Azure, whatever? Figure that out early, because you need to know what APIs you have to call against and develop tooling around. SLAs, right? If you don't have the concept of SLAs, SLIs, SLOs, consider a culture where you have those things in place, and we'll talk on that in a bit. Compliance, the favorite one. Taking credit cards, guess what? That means you're PCI. You're working in healthcare, that's probably HIPAA. So you want to know what restrictions you have and what things you have to build around early on, right, to essentially have delivery into those environments. I always like to argue that effective delivery doesn't really start at delivery. There's a lot of things before, delivering code out the door that you have to consider to make your life easier when you are ready to deliver that software out the door. So what do I mean by that? Take an environment. Again, forget about which provider you use. They all equally work. How do you track infrastructure changes? Are they emails? Are they in tickets? Are they in Terraform? Are they manual? Consider that and figure out how to improve and iterate on those. Core infrastructure requirements, how are they documented? How do you update routing rules? How do you update things like infrastructure configs? How are base images patched, right? What is the patching policy within your organization? And really, the concepts of managed delivery, if your apps have some level of common config, can you automate around it, right? A VM, while it is a challenging beast, generally speaking, the base infrastructure is probably not going to change much in between. The applications running within a VM or the applications running in a container are obviously going to be severely different, but majority of the case, I would argue, is probably 99% the same. So consider that. Doesn't stop there. I mean, even things like source control. How do you structure repositories? Is there a centralized Git admin? How long does it take a developer to create a Git repository? Is it a very locked down procedure? Can they create their own repositories? Do they have access to own merge requests within their team? Things you have to consider. Something that's also not often considered is control what's allowed in a Git repo. I mean, I've seen organizations where folks commit zip files or folks commit EXEs, right? You can totally do it, and there's measures within Git to totally support that, but putting a binary in source, are you changing binary data? Most likely not. But the repercussions that could have is when you're delivering that artifact, it could actually blow up your delivery artifact quite a bit as well. So some things to consider. Continuous integration. How are jobs created? Are they manual? I know I've created manual Jenkins jobs in the past. How many times have, the URL for Artifactory changed because we moved from on-prem to the cloud provider, right? Well, how many Jenkins jobs did we have to update? Who here uses LastPass and has that awesome feature to autofill passwords, and every time you hit save on a Jenkins pipeline, it autofills that password field? That's happened to me. I've taken down production because of that, so I'll admit it. Ultimately, how are artifacts stored, right? You would think things like, oh, just toss it into like an S3 bucket, who cares? But pathing that will be very important down the line, right? So you can find and be able to essentially create an API around your artifacts, being able to find how to deliver and ultimately put those things into like a delivery pipeline. And then we get to Spinnaker. How are pipelines created, right? Spinnaker is a really powerful tool. It allows you to create pipelines manually. But there's also interfaces like managed pipeline templates, formats, a few other tools that allow you to essentially auto-create pipelines based on configuration, declarative pipelines essentially. And do those pipelines allow you to grow that paved road concept. That's definitely one of the more important things, and we'll actually touch on that now. Just a show of hands, how many people are new to Spinnaker, this first time kind of using it? Cool, awesome. Hey, welcome to the community. We really are happy that you're here with us, learning from a bunch of us. Please keep staying involved. We're really happy to have you here. But really, it started as a Netflix open source project in late 2015. There's still a large, growing community out there. But the beauty of it is that it provides a singular interface into all your cloud providers, so AWS, GCP, and many more. Right? It has support for the future. I mean, I don't know about y'all, but I hear articles every day about how we're now Kubernetes. We have a Helm chart, right? Vault, we have a Helm chart. Hey, we have a Helm chart. Obviously, there's some things you have to consider. It's not always as simple, but the fact that it has support for things like Kubernetes is great. It helps build for the future. You get automated canary analysis. This is a really powerful tool, and we'll show an example of that later. But that's something, again, leveraging the power of these big companies that help support this. We kind of all win when we all learn from one another. And that's kind of the view I see within the Spinnaker community, which is awesome. There's a large user base, and the community is awesome. If you haven't really, the speakers, everyone in the community, we're all here to learn, build, see what we're all doing in our various organizations, and see what we can take back, right? These are really awesome companies, and in general, a great community, even if you're not in one of these companies, that we're just trying to learn, ask questions. And it just keeps growing every day, as we can see. I touched on this, but behind the scenes there, that's an AWS deployment and a Kubernetes deployment. Our developers no longer have to do the guesswork of where is my application deployed. They can see that their app is in Kubernetes. They can also see that their application is in AWS, right? And see the versions differences between there as well. So again, one view into your application delivery, which is awesome. Visualizing delivery pipelines. So the beauty of it is not only can you have this awesome GUI to kind of build your software delivery, I argue that you could almost define your business process in a pipeline. It's not necessarily the correct term, but the concepts of we must build our code, we must test our code, we must deliver our code, and we must meet these XYZ requirements, you can essentially use a pipeline to visualize all those steps. Essentially, taking a flow like this, for example, where commits trigger some Jenkins job, Docker gets created, Spinnaker does its magic and pushes out Docker containers, and ultimately codify it, right? At the end of the day, those Spinnaker pipelines are JSON templates, but those simple pipeline steps do severely complex operations. And we'll show how complex just deploying an EC2 server can look. But the beauty of it, that's a feature that's included in the platform. So you and us as a community, we can leverage the learnings of best practice around delivery of those artifacts. So a lot of talking, but it's short. Pick your tools. Preferably, as we saw earlier, there's no shortage of tools out there, but pick something that you're not only comfortable maintaining, but something that you're ultimately comfortable supporting, and ultimately something that's available to grow. Because again, we're not solving for the short problem, we're trying to solve transformation for the entire application stack. Essentially, you're doing it right in my book is if you can read out your delivery like a recipe. Step 1, do this, create a Docker image, pack or whatever. Step 2, scan it for vulnerabilities. Step 3, yada, yada, yada. So we kind of talked a lot of the theoretical, but what do you do now? Well, we start building our tool chain, right? We start implementing tools. But before we do, I'd argue that there should be a significant investment in metrics, especially early on. We should all incorporate metrics, not only at the application stack. So just like how I said that delivery doesn't start at delivery, application metrics should not just end at applications. You should be able to collect metrics like, how long are my builds taking? How long does it take to get from a commit all the way to production? What are the changes in between here? What are there performance differences? Because by correlating both application metrics and delivery metrics, you can start seeing some cool, you could start tracking some cool improvements over time, such as, are we deploying faster? Is what we're doing right? After we made that change, are developers more empowered to roll out that software faster? Are they getting, is there a bug? Are we seeing issues? There's some great talks around actually operating Spinnaker and seeing some great things. So those are some things you should consider as well. And ultimately, by living in transparency and data, arguably we should make that data accessible, clear, and understood, it eliminates personal bias. Oftentimes I get asked the question of, how can we do this in our organization? We don't really have buy-in or whatever. We did this one sample app, but it's hard to visualize that. So I always like to go to this quote, you may disagree with my opinion, but let me show you some data. By leveraging that data, it again eliminates that personal bias, and we're just talking about ones and zeros essentially, saying that, hey, this is working. Our measures, our guiding principle is in fact still in use, right? So something very important to kind of keep in mind. Arguably, try getting past that. That's a hard boss to work for, but he's good. And one more thing. I would be remiss if I did not mention this, that there's no Kubernetes CRD to fix a broken process or culture. No matter how many cool tools you put into an organization, no matter how many awesome developers you hire, if you don't invest in a company culture, you're not going to succeed. You have to take a significant, at least in my book, a significant investment in your engineering staff and build a culture in which you empower engineers to build, deploy, and own their applications end to end. In short, that crazy guy, developers, developers, developers. So you gotta leverage the concept of the paved road, as we talked about earlier, to empower these engineers, right? At Redbox, we don't have a centralized ops team for the cloud. Engineers are the ones deploying their software to production. But this doesn't mean that we just kind of say, here you go, here's admin to the AWS console, have fun, see you in a week, right? No, we don't enforce those implementation details onto the engineers. No one wants to be writing YAML. I know even as a delivery engineer, I hate writing YAML. I can only imagine as an engineer actually writing YAML. Don't expect engineers also to become domain experts, right? There are various domains that you have to touch. You have to touch the networking stack. You have to touch the infrastructure stack. You have security, quality. I can go on and on, right? At the end of the day, where the goal is to give engineers a safe guardrail, as Isaac mentioned this morning, to delivery, not a gate. Essentially, give them a safe path to follow. If they so choose, and the company so chooses to build a path, we can, but essentially it's a discussion and growing that out. Taking that concept, various engineering teams should kind of build on that and work together to build compelling tools and complementary tooling to support that engineering staff. Concept of SREs, helping ensure that we have the baseline metrics. I've seen things like auto-creating dashboards after every deployment, updating open API docs, quality teams running test frameworks, security teams doing vulnerability scans. What does a compelling tool essentially look like? They can have many definitions, but I think that a tool should look to be simple, minimize context switching, and ultimately be accurate with fast feedback. You have to ask yourself, whenever implementing a new tool into your process, into your pipeline, right? Does this solution, the one that we're about to implement, empower engineers to take action? If not, why? What can we do? The idea behind some of these concepts are probably very good, but what do we need to transform, right? A security scan reporting a vulnerability. Will that empower the engineer to want to fix that problem? Does it surface itself within delivery? Does the engineer get enough notice around this? And ultimately, does it provide fast and accurate feedback? Again, trying to feed everything back into that pipeline. Even further to this, we're seeing a trend right now where this is extending past just delivery, and we're seeing this extend into things like infrastructure as well. As we saw Andy and the various Netflix folks talk about managed delivery, but we're seeing the concepts that engineers are looking for more than just a paved road. They're asking for an autonomous vehicle that just takes them where they want to go. And that's where the concepts of managed delivery essentially are coming from. The engineers just want to focus on writing software, and they just want it to be in the environments that they need it. So in short, delivery engineers should focus on implementing tooling that takes a given spec. Like, I need 3 regions. I need 4 gigabytes of RAM, right? Things that probably as infrastructure engineers or delivery engineers, we may know the answer to, but the engineering teams just can focus on the core requirements. And we as delivery engineers can take that concept and build and deliver a best common practice infrastructure, best practice infrastructure, apologies. Essentially, eliminate the guesswork from that. If you haven't seen this talk, it's actually a really good view into the future of where Spinnaker may be going. It was actually yesterday, so you can't actually watch it, but it should be recorded, so definitely check it out. But managed delivery was announced probably 2 weeks ago on the blog post. So what are some examples of compelling solutions, just to kind of wet the feet of what can some of these things look like? So all right, let's do this. Leroy. At Redbox, we built a tool called Leroy because we found that a lot of our engineers were essentially manually creating Jenkins jobs or Spinnaker pipelines, but there was no way to correlate what was actually being created. So the solution that we came up with was the tool is essentially a webhook that listens to Jenkins changes in Git that auto-create Jenkins jobs and auto-create your Spinnaker pipelines. Essentially, this enables core teams, like the Jenkins domains experts, to define the best principles. No longer are developers defining artifact URL in their code, right, or in their delivery pipelines. We will take care of that. You can define as much, but again, the concepts of guardrails, not gates, they can override our settings. If they spin up a test artifactory, for example, they can totally do that. But we will provide you the guardrails to kind of stay on the delivery path. Great. I don't know what just happened there. Oop. We're back. Oop. There we go. Awesome. So continuous delivery and infrastructure. What do we do to solve that? So we created an open source solution, or we actually are part of the open source community for Formas. Essentially, it allows you to create pipelines as code. It's one of the early initiatives to define pipelines as code. The benefit of this is you're able to version and recreate your Spinnaker pipelines, but more importantly, you can standardize base template requirements and ultimately safe infrastructure defaults to give, again, those guardrails now extending into the continuous delivery space. So how does this look in principle? Essentially, the challenge, right? What was the problem? Engineers wanted a declarative way just to define the best practice pipeline. They were tired of going in deck, seeing the example pipeline, and changing it. Again, there's other initiatives out there. This is just one of many, as we saw this past weekend. But this is the solution that we went with. Essentially, you take a given spec. I'm an EC2 deployment that needs to be deployed into East, and I need to hit stage, canary, prod. Taking that data, we're able to transform that into a Spinnaker pipeline that essentially creates what you see on the bottom of the stages that you need to go to. But in addition to that, we extend into the delivery. Formas is two-part software. It also does your pipelines, but it also does your infrastructure. So again, engineers just wanted the best practice infrastructure without having to be domain experts. Same concept. You take a spec, you take a given template, and that infrastructure is created for you. Things like, what's my health check? How many servers, how many pods do I need in my application? Any scaling events? Do you need shadow capacity? Do you need to auto-scale on memory? Do you need to auto-scale on CPU? Ports to expose, et cetera. All defined. This, overall, just a quick overview, Formas supports EC2, Lambda, S3. More importantly, we've heard from the community that Formas may have been too opinionated and focused on AWS, so we have support for custom templates. Essentially, you can define your own Jinja-based templates, feed it any key value pair, and we'll actually take care of creating those pipelines for you. But more so, on the infrastructure side, we have support for AWS Route 53 DNS records. After every time you deploy a new DNS, new ELB, we're able to create you a nice, friendly record for you. So you don't have to remember that internal dash crazy 3322 elb.amazon.com. Classic ELB, ALB, NLB coming, security groups, IAM policies. More importantly, from an availability and uptime perspective, it's able to configure scaling policies as well as scheduled actions. So if you know that every morning at 6 in the morning, marketing is about to run that giant report that just puts that squeeze on your infrastructure, and you know that no matter what, it's always going to be 20 servers. I've done this 3 times. It's always going to be 20 servers. You can prep for that shadow capacity through Spinnaker, through this. It's actually extending a feature within Spinnaker too. It's called scheduled actions. So now with this in mind, you can actually build minimum viable pipelines. Lay out what's truly needed. Lay out what your current flow is. For example, take your last deployment, right? And figure out those top level requirements. Every deployment, we need testing. Every deployment, we need security. Every deployment, we need some level of monitoring. With that in mind, find champions in an organization, folks who want to help improve and deliver, because they are out there. You just got to find them. And ultimately, pick a small application that has high visibility, but ultimately has room for growth. Don't start with your payment services, because if that fails, that's going to cause folks to be skeptical and have doubts and say, is this really worth it? It just took down our revenue source, right? Start with something small that can grow over time. But most importantly, don't let perfect be the enemy of good, right? Create a minimum viable pipeline that can extend, that can grow over time. Essentially, make your deployments boring. You don't want to have deployments look like this, and I know because I've been on this side where you hit that restart on the JBoss server at 1 in the morning, and you're like, oh, I just want to go to bed, and it just comes up with a giant stack trace, right, back in the day. So make your deployments boring. Essentially, make them a click of a button. So let's recap. Incorporate and leverage metrics. Encourage and build self-sufficiency with paved road pipelines. Lay out your minimum viable pipelines and make deployments a click of a button. Now, this is like where everyone's like, yes, I've heard this a million times. But how? How can we actually use Spinnaker to do all this stuff? So you don't understand, Joel. You don't understand. We can't just deploy fast. It's just too risky. It's not, no way. We can't just get rid of dev and stage. That's insane. Developers deploying software? Are you nuts? No way. They can't. They're not experts. They don't know how to do this. We can't automate quality testing, and ultimately, we can't enforce security best practices and do canaries. All right, I lost you. This is impossible. Well, it is, but you have to centralize. I argue that if you centralize the common solution, in this case, Spinnaker, it is possible. So let's just break it down, right? Let's take this tangible list. We can't deploy fast. Developers can't deploy. And I'd argue that in the current iteration, probably, right? If I was to take an existing process to deploy to a data center, there's a lot of things that are done. I have to SSH into the box. I have to copy this artifact. One, I may have to also have root permissions, so maybe I don't want to give them root, right? There's a lot of things you have to kind of lay out to understand before you can actually have a delivery pipeline that actually gives you the ability to do that. The first thing, the goal is to deploy fast, to fail fast, and ultimately, I'd argue, fail forward. But it's not just deploying fast, right? Anyone can deploy fast. I can get an email and I can toss it on the server. I can hit restart on that, no problem. I can do that right now. The goal is to deliver small changes. The challenge today, as we know, these take a 2-week sprint, right? Development's done. An engineer's tasked with delivery. We put that on a server. By the time that code actually goes out the door, the development team and all the various other components around that team have moved on to the next one. So to triage this issue, it also probably touched a lot of teams. Was there a defect, missing quality? Was there a misconfiguration of a server? Was there a fault in the code, right? That could totally happen. But then it turns into this finger-pointing game. Instead, having small automated changes that iterate over time allow you to just focus on delivering those small features, and essentially making them backwards compatible. But it's not easy. You have to remember that when you're building this and you're building your platform, as a measure, whenever you're building it, build a platform that when you roll out a fix, it's faster than as fast as rolling it back. You should have the safeguards to roll back your changes if you need to. And ultimately, as we alluded to, make your deployments, infrastructure, and rollbacks boring. Build around the concepts of immutability to eliminate server bloat. So the concept of cattle, not cats. Just really quickly, I know immutable infrastructure is kind of a new thing, but essentially, instead of just using that existing stack, create a mirrored copy of it, fail traffic over to it. That way, every time you deploy, you're guaranteed that it's a fresh system. In the case of containers, typically it is. And you never really have to worry about patching because you can have an up-to-date image that's rolled out via your internal patch review process. You have the ability to do things like blue-green, right? You have your old server, you have your new server. Let's see if it's actually working. It is, destroy the old one. But if you have to roll back, since you have that automated and you have that all defined, it's just a click of a button. So in addition to that, when using Spinnaker, it's not just deploy an EC2 instance and we're done, right? It actually has quite a few checks. So for example, in this environment here, it's saying deploy to US East, disable the old cluster, shrink it to 0, and then restore minimum capacity. But even within those subsequent stages, just the deployment aspect, it's just making sure that the health provider path, it's like, for example, monitor the deployment, force cache refresh, wait for up instances, using those best principles as determining, is this deployment truly healthy? Again, I mentioned this earlier, a centralized view into all your deployments, and ultimately has built-in rollback support too. You can go ahead and click a button within the UI and roll back to a previous version. In the event, for example, here, 2.11, just hit roll back, type a reason why, boom, that's all sourced within Spinnaker. Click of a button. The next one, we just can't get rid of dev 1, dev 4, pre-prod, pre-prod. I've seen that come up. You joke, but I've seen it come up. But why do these environments exist, right? Let's ask the fundamental question. We've done a lot of talking today. So why do these environments exist? Most likely to check the health and ensure uptime, right? You want a safe little area to deploy and minimize the blast radius. And ultimately, maybe to deploy and test multiple complex changes, right? But the truth around dev and stage, I argue, is they stink. They often do stink. Can anyone reliably simulate a production workload of XYZ hundreds of thousands of users in stage? How much effort do you have to do to maintain that production environment, ensuring you have that up-to-date data? The argument I always hear is, how good is your test data? Is your test data the same as production quality? And how much is your stage environment costing you? Typically, in a high-velocity organization, what I've seen is, if it's done right, stage is kind of like, oh, we just have to always hit next on stage for some reason. Just, we have to hit to go to prod. It's more like a chore than anything else. I'd argue, so we always, I kind of had to include this actually, because there was an era within software delivery where we saw this kind of meme everywhere, right? Like, it was kind of funny, like, haha, yeah, we should never test in prod kind of thing. But I'd argue, why not? Why not? Why shouldn't we? Maybe it's just a sign that we're getting kind of crazy. I don't know. We've been doing this for now, it's DevOps, SRE, whatever, for 7, 8, 10 years now. Maybe we're just kind of all getting kind of crazy in the industry. But maybe it's a sign of confidence, right? Maybe it's a sign of maturity in all the tools that we're implementing in our day-to-day. Things like canary rollouts help alleviate the need for a staging environment. So, for example, at Redbox, we use Istio within our Kubernetes cluster to do something like this. I like to always visualize, forget even how to do this. Traffic coming in, probably 99% of traffic coming in on the left. Going to Istio, always goes to view 1. However, hello, I'm Joel. I hit Istio, route me to version 2. Or, hi, I'm the quality team sourcing from this IP in the Redbox offices. I want to see version 2 and test. I'm coming from this version of a laptop, of this version of a browser. Being able to do that layer 7 routing, essentially letting you deploy to prod, but do that testing as well in there. So ensuring that when this ultimately goes to live, you've done your due diligence and you've checked against this in production. Let's level this up. You can even do granular canaries. By getting rid of stage, we can now have 2 more production environments. And ultimately, that's a better user experience for our customers. geo-distributed regions across the United States to help deliver a faster experience for our customers. But now we could also do regional-based canaries, such that only the central region sees this. We could do it in all three if we need to, right? But again, thinking outside the box and layering that in. Talked a lot about canaries, but within Spinnaker, there's support for built-in canary analysis and automated canary analysis on top of that. But in short, if you wire it up, and there was an awesome, awesome workshop here that I hope a lot of folks took the advantage of, it allows you to evaluate very complex metrics such as, did I pass my CPU criteria? Did I pass my error rates? Was my latency an up or down? How many TCP connections did I handle? Was that good or bad? And at the end of the day, it'll generate a score, and essentially, just like going to school, it'll say, well, if you get a 75, you technically pass. If you got a 95, you're in the honor roll, or whatever, right? Essentially, that's the way I always like to equate to something like that. But using that data, you can actually effectively do automated delivery as well from this. The next one, we can't automate quality testing. What are you talking about? Correct. You can't just automate it. You have to do an investment in quality engineering. This is the gotcha of the talk. Quality engineers should be empowered to write code and test as closest to the source as possible. However, for the developers in the crowd, this does not mean they're going to write your unit tests. You're still on the hook for that. Quality testing essentially should be built into the pipeline, and there's no reason for it not to be. With a powerful tool like Spinnaker, as we'll see, you can easily do that. And at the end of the day, automated testing and pipelines will provide that fast feedback that I was talking about earlier. If that fails, developers can then click in and see, why did it fail? Oh, look, I missed a test case. The login call all of a sudden spiked to 200 milliseconds because of a Redis timeout. I don't know. Me going crazy. So how does this look in practice? Look, I'm not going to here to preach which way is better within Spinnaker. Every organization is different. For us to get started, we did a Jenkins job. We triggered a Jenkins job, did a Gradle build, boom. Is it cool? Probably not. Is it a presentation worry? Probably not. But it works, and that's the most important thing, because at the end of the day, even 50% automated is better than 100% manual. It gives you that time back to spend that other 50% that now is automated to focus. Hey, maybe we could do the next 25%, right? Maybe we could do the next, we can invest in other tooling, right? Giving time back to those quality engineers to build that platform. And in short, it could look as simple as this. Hey, I have a quality step. Trigger this Jenkins job. We're super cool. We have a Jenkins quality test now. You can't automate best practices security. What are you talking about? Well, it's sometimes lost, but when delivering VMs and EC2 to like AWS, for example, under the hood, the bake step actually uses Packer. And Packer is essentially a tool that can take, there's filters within Packer to essentially find the latest image based on your criteria. So you can ensure that every time you deploy, you're always using your latest curated base image whenever you deploy through Spinnaker. So that's awesome, partnering a tool like Packer into your pipeline. It's natively supported. You don't have to do anything. You can integrate security steps. Just like the quality step, you can do a post to some security tool out there, do a scan, do a test, whatever you need to do. Again, fast feedback right within that pipeline. That report can be generated for your engineers. And we can't automate compliance. Many companies instill DevOps practices until they see these words, PCI, SOX, HIPAA, right? After that, it's like, that's it, we're done, that's it. I'd argue that automation and a culture of automation, compliance is actually a good measure of whether you're staying true to your principles, right? Embrace the challenge. Don't just turn away and say, like, that's it. Like, we'll just kind of leave the PCI stuff over there. Embrace that challenge and see what you can automate. Because again, even 50% automated is better than 100% manual. And I know that audit season is always coming around. It's coming around the corner, and it's always like a 2-week loss of work where you're just trying to figure out and collect evidence. So within Spinnaker, lock the front door and check the rooms to the key. At the minimum, everyone in the crowd should look to enforce some level of SAML, OAuth, LDAP, X509, something. Spinnaker is a really powerful tool. It can do a lot of damage, so make sure at the very least you have to authenticate into your system. But more importantly, look at something like Fiat within Spinnaker to control access to specific resources to make sure you limit the blast radius as well. You could do things like locking your pipelines such that a pipeline can be updated via your prescribed process. But again, guardrails, not gates. Guardrails, not gates. Audit approval. Commonly heard is developers can't deploy because they can't deploy their own change. Simple step, solved it in probably 2 lines of spell. Look at who just hit the OK button, look at who just did the commit in Jenkins, boom, done. You have an audit check. The developer who wrote that piece of software can't be the same one who's deploying it. Change control. It's no brainer. There should be no restrictions against this. This should be an awesome feature. Who, what, where, when, why. Why were things changed? And this is an example, take it from us at Redbox. Again, the app name, the environment, the approver, down to the commit granularity. You're able to then click that button and say, what is exactly changing when Joel hit OK at midnight to get this change out the door? And show me the Spinnaker ID. I want to see all the steps. I want to verify that this was actually tested and everything. There's a great article out there on the Spinnaker on the Spinnaker docs. It's kind of lost. You can add a webhook to essentially just be an event bus and listen to that. It's actually pretty cool because you essentially can build some cool events, as you can see from there. So in summary, Spinnaker for us has been a huge productivity gain. These are just the numbers from when we started all the way to now. Our delivery team was initially only 2 people, and in the past year, we're now 5. At development staff, with about 40 to 50 people, and that's growing over the time. With this in mind, Spinnaker allowed us to deploy to 2 cloud providers. We're in 5 regions. We have hundreds of Spinnaker applications, thousands of servers, that's beside the point, but over 1,200 deployments a month. And those were all developer-driven to production by a click of a button. So essentially, the takeaways that I hope everyone takes away from this is build a culture and empower your engineers to own their code. So you build it, you run it. Don't let perfect be the enemy of good. You want to have something that's minimum, that's viable, and grows over time. Start small. Going fast does not mean compromising quality. It does not mean you can just skip over security and ultimately your compliance steps. Provide developer guardrails, not gates, and give them safe defaults and enforce standards. And ultimately, Spinnaker's pretty awesome. I hope everyone agrees with that. To find out more about this stuff, we're going to be publishing here soon an article about how we use Spinnaker at Redbox. In addition to that, we have a few other things, so please check out our tech blog for more information around kind of cool things that we're doing in our transformation journey. But with that, thank you so much. I know you all had a lot of talks you could have picked, and it really means a lot that you picked mine. So thank you, everybody. Thank you, thank you.